It's summer, and it's hot.
If you had to wear one of these shirts on a hot day, which one would you choose? Black or white? Well, of course it's the white one, right? But why?
Depending on the material of an object, a t-shirt reflects certain wavelengths of electromagnetic radiation. The color we see depends on the different wavelengths of light that the t-shirt reflects. In the case of a black t-shirt, it absorbs almost all of the visible light, creating the dark color. And in the case of a white one, most visible light on the spectrum is reflected back to us. Everything in the universe interacts with electromagnetic radiation in different ways.
This is a blackbody, an ideal object that absorbs and emits all types of electromagnetic waves. It absorbs all the light coming in and gets heated from the radiation. Then it emits it all out to cool down and be in equilibrium with its surroundings. This light is comparable to a light bulb filament or a hot piece of iron. A perfect blackbody technically cannot exist, and we haven't found one yet either, but there are some close examples.
The sun is a blackbody. It absorbs almost all electromagnetic radiation and emits it out. And an oven is close too. It glows when it's hot and appears black when it's not. So two scientists, Lord Rayleigh and Sir James Jeans, derived a formula for the intensity of light emitted by a blackbody. Now, it might look a bit complicated, but all we have to know is that the frequency is in a quadratic relationship with the intensity, meaning that the greater the frequency, the stronger the radiation. According to the formula, if a blackbody absorbs high-frequency radiation such as ultraviolet waves, it would emit them back out at an insanely high intensity. However, when scientists experimented in the lab, this wasn't what happened. Let's take a look at the graph. This line represents the expected intensity of the light emission, and these lines represent our experiments. For some reason, the intensity dips after a certain point. This problem stumped scientists for a long time, and it was called the ultraviolet catastrophe. Some time later, another guy named Max Planck came along. He looked at the graph and said, "Hey, this isn't convenient at all." Then he solved the problem. Planck proposed that energy is quantized, which means that it can only take on integer multiples of a base amount of energy. He used his theory and remodeled the formula, and bam! The graph correctly shifts downward after the frequencies got higher and higher.
This discovery was groundbreaking. Even though Planck only proposed it as a mathematical solution, later on, scientists were able to theoretically prove it.
The fact that energy is quantized became the basis for modern physics.
So in the end, is our black t-shirt a blackbody? No, but you'd be much better off wearing the white one.